Hey everyone, and welcome. Today we are jumping into something called spec thinking. It's this really cool mindset that the absolute top security auditors use to find those deep, critical bugs in smart contracts. And it goes way, way beyond just ticking boxes on a checklist.
So let me start with a question that might sound a little weird. What if the deadliest bugs aren't actually in the code? I know, but hear me out. We usually think of a bug as, a typo or a simple mistake. But what if the really catastrophic failures, the ones that drain millions, aren't about syntax at all? What if they're about a fundamental gap in understanding what the system was supposed to do in the first place?
And this right here, this shows you the big shift. On one side, you've got your traditional checklist auditing. It's reactive. It's looking for problems we already know about. But on the other side, you've got spec thinking. It's proactive. It's not looking for known bugs, it's hunting for the unknown. Those broken assumptions that create brand new, totally unexpected ways to attack a system. Yeah, to really truly secure a protocol, the best auditors just throw out the rigid checklists. What they do instead is they basically create a new checklist on the fly for every single project by digging deep into the system's core logic and all those unwritten rules. So here's the absolute key takeaway. A bug isn't just a coding error. It's a mismatch. It's that dangerous gap between what a user expects to happen, what the developer meant to happen, and what the code actually lets you do. And it's right there, in those gaps, those broken assumptions, that the real danger is hiding. So to find those gaps, you can't just open up the code and start reading from line 1. Nope. You have to go all the way back to first principles. We have to break any smart contract system down into its 3 core foundational pillars. First up, we've got the asset. This is the what. It's the valuable stuff in the system. Could be money, could be voting power, could be ownership of an NFT. And there's a great little rule of thumb for this. If it's something that can be transferred, it's an asset. Simple as that. Pillar number 2 is the actor. This is the who. And listen, this is super important. It's not just your average user. An actor is any entity that can touch the system. That could be another protocol, a malicious attacker, or even the contract talking to itself. The easy cue here is, if it can be identified by an address, it's an actor. And finally, we have the action. This is the how. It's the spark, the trigger. It's when an actor does something that kicks off the system's logic. It's the verb that makes everything happen, potentially changing the whole state of the system. Okay, so now that we have our building blocks, our assets, actors, and actions, we can start building a totally new framework for seeing bugs. And we're going to stop using technical jargon like reentrancy and start categorizing bugs by what they actually do to the system's logic. Now, this is a really, really important distinction to make. So missing paths, that's the easy one. A feature you thought was there just isn't. Then you have incorrect happy paths. This is all about bad data. Think of it like a calculator where you type in 2 plus 2 and it spits out 5. You did everything right, but the answer was wrong. But the last one, unexpected paths, this is about bad control. This is the system doing something it was never, ever supposed to do. It's like a secret door opening up that shouldn't even exist. And this is where the most devastating hacks almost always come from. So how on earth do we find these logical failures? Well, the heart and soul of spec thinking is a set of 3 simple, but believe me, incredibly powerful questions that will guide your entire investigation. And here they are. What is expected? What is allowed? And what was assumed? By asking these 3 questions in this exact order, you can systematically peel back the layers of any contract and expose its hidden dangers. Let's break each one down. First, what is expected? This is what we call the value layer. It's all about making sure the good things the system promises can actually happen. What are the core features? Does the happy path actually work? You have to establish this baseline first. Next up, what is allowed? Welcome to the possibility layer. And this is where your whole mindset has to shift. You stop thinking like an engineer building the happy path, and you start thinking like a detective or an attacker. You're now exploring every single thing the code can be forced to do, whether it was intended or not. This is where you hunt for those dangerous, unexpected paths. And finally, the third prompt, and this one is the real kicker. What was assumed but never enforced? This is the enforcement layer. It's about all those things the developer just knew to be true but never actually checked for in the code. Our job here is to take those silent, implicit assumptions and turn them into explicit, rock-solid rules that we can actually test against the code. Okay, this all sounds awesome, but let's be realistic. A complex protocol can have like a near infinite number of possible interaction paths. So how do you actually apply this without getting totally lost in the weeds? The answer is a really clever strategy called sync source thinking. Right, this is the number one problem for any auditor. It's called path explosion. There are just too many possibilities. You literally don't have enough time in the universe to check everything. So you've got to find a way to focus your energy on what really truly matters. And that brings us to this brilliant idea of a sink. A sink is a critical spot in the code. It's the place where the absolute worst-case scenario can happen, where assets get sent out, where admin control gets handed over, where critical data gets corrupted. If something goes wrong at a sink, it's game over.
So the strategy just completely flips the script. Instead of trying to follow every possible input from the start, you find the most dangerous sinks and you start your analysis there, at the end.
And from that sink, you work backwards. You ask, what user inputs could possibly influence this critical function? What stored values does it depend on? And you have to adopt this paranoid mindset. You have to assume every single input is malicious, and that any other contract you call is a chaotic liar that is actively trying to break your system. So let's put all the pieces together now. The 3 prompts and this sync source strategy, they combine to form a single, powerful, and repeatable process you can use to audit any protocol out there. And this is the loop. It's a 4-step dance. 1. You define what the system is supposed to do, the expected path. 2. You find the sinks where the worst damage can happen. 3. You trace all the possible paths, everything that's allowed that could possibly lead an attacker to those sinks. And 4, you challenge every single assumption you find along those paths by writing down hard rules. I mean, it's such a beautifully simple philosophy when you boil it down, right? Start with what matters, the sinks. Follow what's possible, all the allowed paths. And by doing that, you catch what's unsafe, all those broken assumptions. So if you take away one thing, let it be this. True security isn't just about the code that you write down, it's about all the assumptions that you don't. And that really just leaves one final question for you to think about. What hidden assumption in your project is just sitting there, waiting to be broken? Thanks for tuning in.